Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 31. 4 Year 12 students want to organize a graduation party. 4 students have the same probability of being available next Friday. All 4 students have the same probability of being available next Saturday. Kim is one of the 4 students. Is Kim's availability next Friday independent from his availability next Saturday? So first of all, we know that if probability of A and B are independent, so this means that probability of A given B is equal to probability of A. So keep that in mind. So therefore, the probability available next Friday, so that is probability of F. F is Friday, and given that S, that is Saturday, so that means we have 1/8 here. So equal 1/8. That is probability of F is equal to 3/10. So therefore, probability of F given S is different from probability of F. So therefore, so there you go. So therefore, they are not independent. Part B, show that the probability that Kim is available next Saturday is 4/5. So first of all, we know that probability of S, that is Saturday, given that F, that is next Friday, is equal to probability of S and F over probability of F. And if I times probability of F on both sides, so that is we times probability of F and we times probability of F here. So this cancel out. So this means that probability of F and times probability of S given F is equal to probability of available next Saturday and next Friday. So now we know that probability of F is 3/10. So let me write this down, equal 3/10, and we times probability of S given F. So this is 1/3. So times 1/3. So that will give me P of S and F. So now we just cancel this out. This cancel with this. So give me 1/10. So that is probability of S and F. And we also know that probability of F given S is probability of F and S over probability of S. So now if I times probability of S on both sides, so I times probability of S and we times probability of S. So that cancel out. So this will give me P of S and times P of F given S. So that is probability of F and S. So now we know that probability of F given S is this 1/8. So therefore probability of S we times by 1/8. So 1/8 is probability of F and S. But don't forget, probability of F and S is exactly the same as probability of S and F. So that is here. So 110. So let me just write 110 down. So is equal to 110. So what I do, I times 8 on this side and I times 8 on this side. So this cancel with this. So therefore, probability of S is equal to, so 8 over 10. So 8 over 10, I can simplify. So if it's 8 over 10, if I half of both, so that give me 4 over 5. So 4/5. So there you go. So the probability of available next Saturday is 4/5. Part C. What is the probability that at least one of the 4 students is not available next Saturday? So to work this out, so we just need to have 1 minus all the students available next Saturday. So if you think about it, so let me just explain this by drawing 3 diagrams for you. So the first student is available, not available. And the next students is available, not available, okay, on next Saturday. And that's the second students. And then the third one, I, not I mean available next Saturday, okay? So it's like this. And you don't have to draw it. I just explain it to you so you know what it's like. So I, not I. I, not I. And this is so far only 3 students, and I need to do one more. So I, not I. I, not I, and so on. So we want to have this, and so on. At least, okay, one of them not available. Okay, that's the questions. But then we know that all the probability add together must give me one whole. So we just want all of those except this one here. So what I do, I just go 1 minus that. And all of the student available is this. So the probability available, okay, next Saturday is 4/5, right? And we know that from this part, okay, available is 4/5. So now, so all student available next Saturday, so we just time by 4/5 for the second student, third student, and then the fourth student, and so on. So now we want 1 minus that. So therefore, the probability at least one student's not available next Saturday. So that means 1 minus all of them available. So that means 4/5 power 4. Okay, that means all of them available. So we don't want that. So we minus that out from 1. So that will give me, so I'll just go 1 minus brackets 4/5 and power of 4. So there you go. So 0.5904. So equal 0.5904. So there you go. Question 32. So we need to show that the area bounded by the 2 curves and the y-axis as shaded in the diagram is this. 1/4 ln of 2 minus 1/8. So we just need to work out the area of this. Okay, and it should give us this answer here. So now to work this out, and we know that this function here is on top of these functions. So that is, we just go the top functions minus the bottom functions, and then we integrate from 0 to ln of 2. Keep that in mind, okay? So area I is integrations from 0 to ln of 2. So ln 2. And the first functions, that is the top one, that is e to the negative 2x. We minus the bottom functions. So that means minus more than one term. So we open bracket e to the negative x minus 1/4. And then bracket dx. So there you go. So what I do, let me just expand the bracket first. So that is equal to integration from 0 to ln2 e to the negative 2x. We minus e to the negative x, and minus times a negative a quarter becomes plus a quarter, and then dx. So now I just integrate this. So that will give me integrate of e to the negative 2x. So we differentiate this, give me negative 2. So we just divide by negative 2. So that give me negative 1 over 2 e to the negative 2x. And then we integrate the second one. So we differentiate this, give me negative 1. So we just divide by negative 1. So negative divided by negative give you a positive. So plus e to the negative x. And then we integrate a quarter, give me a quarter of x. So there you go. And it's from 0 to ln2. So now I just evaluate this. So x is ln of 2. So that will give me negative a half e to the negative 2 ln2. We add e to the x is ln2, so negative ln2. We plus a quarter of ln2. And then we minus, so x is 0, so that becomes negative a half times e to the negative 2 times 0. So negative 2 times 0 is 0. So e power 0 is 1. 1 times negative a half is a negative half. So keep that in mind. And then we add e to the power of 0, give me 1. So that means 1. And a quarter of 0 is 0. So plus 0. So there you go. Let's simplify this even further. So if you think about it, we have the first term here is e to the negative 2 ln2. So we can bring this up equal e to the ln 2 to the power of negative 2. And 2 to the power of negative 2 is a quarter. So ln a quarter. So we simplify this cancel out. So become a quarter. So that is negative a half times a quarter. And we add, then we have e to the negative ln2. So e to the negative ln2, this negative 1 bring on top. So that becomes e to the ln 2 power of negative 1. That means 2 to the power of negative 1 is a half. So that becomes e to the ln a half. So this means that we cancel each other out. So become a half. So the answer is a half. And we add a quarter of ln2. And this one, we know that this add together will give me a half. So minus a half. So there you go. So now we can just simply cancel this out. And we have negative half times 4 give me negative 1/8. But I write the negative in the back. So equal to a quarter of ln2 minus 1/8. So that's the answer. So a quarter ln2 minus 1/8. So there you go. Part B. Find the value of k such that the curve y is equal to e to negative 2x and y equal e to the negative x plus k intersect at 2 points. So this means that the two equations, they equal each other, and we just try to solve it. And we know that they must intersect at 2 points. So we can find the value of k or set a condition for it, okay? So that means we have e to negative 2x is equal to e to the negative x plus k. And we just rearrange it. So therefore, this becomes like this. E to the negative 2x minus e to the negative x minus k is 0. And to solve this, so let me just make m is equal to e to the negative x. So let m is e to the negative x. So therefore, m squared must be equal to e to the negative x squared. So from log law, so negative x times 2 is negative 2x. So let me just rewrite this. So negative 2x, okay? So now that becomes m squared minus m minus k is 0. Now to solve for m, of course, we need to use quadratic formulas. So that means m equal negative b. So b is 1. So negative, negative, give me positive. So it's 1. Plus or minus b squared. So negative 1 squared, give me 1. And minus 4 times a is 1. And times c is negative k, times negative k. And square root over 2 times a is 1. Okay, so that means 2 times 1 is 2. So that's what that meant. So this means that m is equal to 1 plus or minus 1. And don't forget, we have a negative times a negative become positive. And 4 times 1 times k will give me 4k. So that means plus 4k square root over 2. Okay, so m is equal to e to the negative x. So let me just rewrite this. Okay, so this means that e to negative x is equal to 1 plus or minus 1 plus 4k square root of that over 2. So now there is two conditions. The first conditions is in order to have two solutions, okay, this inside here must be greater than 1. So that we have 1 positive and 1 for negative. So now let me just write it on here. So this means that first conditions is 1 plus 4k must be greater than 0. And to solve for this, so what I do, I just move this one on that side. So 4k is greater than negative 1. We divide by 4. So that means k must greater than negative 1 over 4. So that's the first condition. And the other condition is we know that e to the power of negative x is never less than 0. So because if you think about it, okay, e to the negative x, the graph is like this. So it's never below 0. So in another word, this here must greater than 0. And we know that the positive 1 plus square root of 1 plus 4k over 2 is positive anyway. We only need to concern about the negative 1. So in another word, we need to know that 1 minus 1 plus 4k square root of that over 2 must greater than 0. Because e to the negative x must greater than 0. So keep that in mind. So if I times 2 on both sides, so that will also give me 1 minus 1 plus 4k square root must greater than 0. So I move the negative square root of 1 plus 4k on this side. So this will give me 1 is greater than 1 plus 4k. And I square root both sides. So 1 square also 1. And square root square we cancel out. 1 plus 4k. And then I move this one on that side, become minus. So 1 minus 1 is 0. So that is 0 less than 4k. And I divide by 4 on both sides. So that means 0 less than k. So we have 0 is greater than k, or k less than 0 and k greater than negative a quarter. So the final products is this. So think about it. We have negative a quarter here and we have 0 here. K is greater than this and k is less than 0. So the final answer is between negative a quarter and 0. So therefore, k is greater than negative 1 over 4 and less than 0. So there you go. And thank you so much for watching. Bye.